Hello techies, welcome to IT Tech Solution. Today in this video, I'm going to demonstrate the error handling in step function. So step function also provides the inbuilt error handling, and it saves a lot of time and effort if we want to implement the same thing maybe in the Python or in the script that we are calling using these step functions. It would be really difficult, but it's very easy. It is already provided in the step function, and we'll see how we can do that using error handling functionality. So here, if you see, this is something similar to the one that we had created in the last tutorial. If you haven't seen the parallel step video, please, I would recommend to see that video first. It will make things more clear because we are using the same template what we had created in that, and then we will introduce error handling in this. So what we had done last time is we had created two parallel streams, and we are just running few lambda functions. We have added some wait states just to check and to wait the process and see how it executes. So wait state is nothing but just to give me 5 seconds or 15 seconds to watch how this step function executes. And lambda functions I'm using, so here I have changed the lambda functions a little bit. I'll be using two lambda functions. First lambda will fail, it will issue an exit command, so that I want to fail and then handle that using error handling. Second lambda won't do anything, it will just return a successful message. So if we see the lambda 2, it will be always a successful lambda, it won't fail. Just a simple return. But lambda 1, if you check, it is having an exit statement in it which will return an exit of 1, and then it will throw that error as system exit. So this is just to fail that lambda. So these two lambdas I'll be using. So first in first stream, as you can see, I'm using lambda 1. So lambda 1 output, if you see, it says that it exited without providing a reason. Basically it failed that lambda, right? So now I want to handle it, because if you see, once this any state fails, it won't execute any subsequent states in that, right? Like for example, here lambda 2, it did not execute, and this entire step function, it is in failed state now. So even if we see the logging of this, it says as failed, right? So this one is failed. But there are scenarios where we don't want to fail the step function, because sometimes what happens in production environment, and so many failures is not good. This will generate some error messages or alert messages saying that your lambda function is failing. And then it's not like very nice to have so many failed states in the lambda in the step function, right? So as a general rule, what we have to do is, anyways, this lambda should this entire step function should have a state of past. Inside it we can have these failed states, but I want to execute lambda 2 as well, because there are some maybe steps that I need to run which is not maybe dependent on one, okay, lambda 1 or the previous state. Very well, I can still execute this lambda 2. So in those kind of scenarios, we should handle the errors that we are getting here. Still lambda 2 should execute, but here it failed, right? Because I'm not currently handling the errors in this right now. So let's just jump over to the studio where we design this, and we will introduce those error handlings, and we'll see how it behaves. So now, as you saw, lambda 2 did not execute because lambda 1 failed. So let's see lambda 1 how we can have the error handling in this. So here, if you just click on this one, it will open the side panel, this one, and here you can see error handling is the last option. So we'll just go to the error handling now, because other options we have already seen in the previous tutorials. I'll just cover the error handling now. So here by default, if you see the code also, right, it creates some retry logics. It already has default logic for retries. So now if we just see the retry logic for lambda 1, it is already there, right? Retry 1, and these are the error functions that we just now saw in the code. And this is the interval that we want to give before the first retry. When it starts to retry, the maximum attempts, how many times we want to try the retry logic, for how many attempts, and what is the backoff rate. So after each retry, it will delay by 2 seconds, and then it will keep on multiplying. So the multiplier we can give here. There is also option for max delays. If we want to add any delays, we can add. So this is by default already added. We can change any of these parameters. But now we are more interested in catching this error. So in this we will just add a new catcher here. So we'll just go to add a catcher, and then in this comments is optional. We can add any comment for what error you are adding. Now we have to identify the error. So what errors you want to catch, right? If there are some specific errors that you want to catch, like let's say timeout error, that also we can have. Once it times out, it will retry, and then we have to say if it again fails, what we have to do, that we will have to define here. So based on the error type also we can do. The most generic is states all. So whatever is the reason, if it fails right with any error, it will catch this by states dot all. Any error it will be catching. So task failed also is one very common error that we get. If anything happens, obviously that task will fail. So timeout, task fails, and task all. When we are giving task all, it should be the only condition, because all means it will cover everything. So no need to give these other errors and then task all. Even if we give, it will say that error, that task all should only be the last one. So if I try to save this, you will see that it gives this give the error that states dot all must appear alone, because if we give states all, it covers everything, so no need to give this. So but now let's just stick with task fails. So now when my task lambda 1 fails, what I want to do, I want maybe to do something with result path or something, we can filter or do something, but I want to just give a fallback state. So I want to even if even the first lambda fails, I want to execute my second lambda. So we can just give a fallback state as lambda 2. Even if the first lambda fails, I still want to run my lambda 2. And lambda 2 will always be a successful, because it just returns the value. So I am giving that even if first lambda fails, I want to trigger lambda 2, right? Now let's just save this and try to execute. Now we will see what the result is. So here it started, both the parallel steps is running. You will see that lambda 1 will still fail, but it's in orange color, so caught error. Now it is in caught error. So there is some error, but it did not result my entire step function to fail. If I just see the error, I mean the run log, you will see that it succeeded. So as a whole, a lambda function succeeded, and it just has a failure in lambda 1. So here we can have some SNS notification that lambda 1 failed integrated into this, so that we will know that in step function my lambda failed, but as a whole this step function is it completed fine. That was because I have added the error handling, and I'm saying even if it errors out, please run the second lambda. Here you can see that arrow as well. Same thing I can do with my lambda 2. Right now, my lambda 2 is not a failing lambda. If I give here lambda 1, it is a failing lambda, right? So this state will in that case fail. So I will just give my lambda 1, and if I just want to run this, we'll save this, and I will just execute it once again. And now since this step that I'm running now is not handled, right, it will come and fail in that state. And as a result, this entire step function will be in a failed state. So it is in a failed state. That is because I don't have any try catch for lambda 2. So let's introduce a try for a catcher for lambda 2 as well. So I mean it is basically running lambda 1, that is the failing lambda. So let's add a catcher. So retryer is already there by default. Add a new catcher we will do. In this again, I'll just say for this time, let's take states all. Okay, so any error which comes in this state, it will capture it. Fallback state, I want to end this now. If it fails, successfully end my step function. But here you can see that go to end is not supported. That is because in parallel step, we can't directly end go to the jump to the end state. So we have to come out of this parallel state and then we can go to end. So for that we will have to introduce a pass state first. So we'll just add a pass state at the end. Okay. Now in lambda 2, then I will in my catcher I can say that jump to the pass state. So pass 1 is the last one. Now pass state will then go to, if you see the pass state, its next state is go to end. So directly from here we can't go to end. We'll have to add a pass state here. So now lambda 2 catcher we have added, and we are saying that even if this one also fails, please go to end and complete my step function. Now if you see, if I just run it again, and then I will see that my step function will still complete successfully, but these two will be in failed state. So let's just see. So yeah, you can see these two step has failed, and it is because of that exit that we are using. This is also is failing, but successfully is getting passed to first lambda, I mean to pass state, and from there it is completing successfully. So if we just see the execution status, final status, it is succeeded, and as a whole my step function got completed. So this way we can add as many catchers as per our need. We can add on all those catchers based on different conditions. So all these conditions, if you want to be very specific, we can have all those conditions here. In some scenarios, you might not want to run lambda 2, right? After maybe the first lambda fails, you want to terminate it, or you want to just jump to past state. So that also we can do. So in lambda 1, we can go to the catcher block. Here in the catcher, you can say that fallback state, I want to go to past state. So I don't want to run my lambda 2. Now you see the flow has changed. So when the lambda 1 is successful, then only it will come to lambda 2. Suppose there is very hard dependency between these two lambdas, right? So in that case, we don't want, if the lambda 1 fails, no need to run lambda 2 at all. It will obviously fail. If that is the scenario, we directly will say go to past state and end this step function. So this way also we can change it. And lambda 2 again, it will have its own catch. If it fails, anyways we have to pass, go to pass state. Even if it runs successfully, then also it has to anyways go to pass state. So we can just run this as well and see that if lambda 1 fails, let us select the failed lambda here. So it's already a failed lambda, lambda 1. Lambda 2 also is a failed lambda. Let's do one thing. We'll go with lambda 2. Lambda 2 is a successful lambda, right? But we will see still it won't get executed because the flow will jump directly to the past state. So let's just see this. I'll just execute it once again. And here you will see that the second lambda will get bypassed. Let's see how this flow goes. So both of these streams are running, you can see, right? So lambda 1 failed, and we added a catch, right, that if lambda fails, my fallback state is pass state. I don't want to run lambda 2. So lambda 2 will not at all run. It will send out the notification, or whatever your project requirement is. It will send out the notification saying that the first block has failed, please check. But as a whole, this step function will be passed. So here are few more parameters that is recommended to use. I will just brief you about that. So here are some timeouts and other parameters that we can set, and it's always recommended and a good practice, for each state we can have a timeout state. So if you know that your a particular step will should run only for 1 minute, and if it runs more than 1 minute, there is some problem. So we can define that timeout seconds. Okay, so we can say enter timeout seconds, and maybe in seconds we can say that maybe 120 seconds is make it as a failed state. okay, because I know that my process should get completed in 1 minute. Beyond that it should not run. So these things are effective to maintain your costs as well. Unnecessary any lambda or anything should not keep on waiting. If you know that your process should run in 1 minute, maybe give a timeout of 120 seconds, and after 120 seconds this will definitely then be in timed out error, so it will keep make that state as timed out. So those kind of good practice we can use, and as I said, right, a retry will already be present there. These retry options whatever we gave is it also comes here also. So if you see that this task failed, right, lambda 1 failed, so it will then try to run it once again. But ultimately it will try for whatever number of retries we have given. It will try, you can see it tried again here, lambda 1, but it again failed, exited, right? So next time what it happened is it will jump to the next step and mark our step function has come. But here it is retrying, so it will retry. So by default whatever we retry option we give, it will try to do a retry here, okay, and ultimately that step function will get completed successfully. So that retry option is already there. We added a catcher, so let's see how that catcher looks at the backend code. So if you see now a new block added here, next is lambda 2 and a catch block got added here. And in catch block, the one that we defined, we said that error equals to task failed. So what happens when task fails? Next is pass. So it will go to pass 1. And just now I added timeout seconds, right? 120. So that also is now reflecting here as 120 seconds. So if we see for second block, right, what is the, I had added states dot all as error. So if this block errors with whatever comes like state dot all means it will cover everything. Next state is pass state, and go to pass state, and then it will next step will be pass, and then it will be completing. So this way we can define the flow, and we can define the catch and error blocks which it handles. Step function itself handles it very nicely, and it's easy to implement also. I'll be back with some other next video. Until then, bye bye, have a nice day.